All right. This was at this point months ago, talking on the Discord, and people were kind of like talking about what is even the point of the quantum mechanics sequences.
I feel you guys.
And here is another thing that came up, which I'm like, okay, I want to do it for completion's sake. I want to do it like just to show that I can do it. And there are some other mini benefits, which I think this is one of them. The assumptions that the collapse theories make, the Copenhagen interpretation, are just legit nonsensical. Cannot exist in a causal physical universe. They are as nonsensical as positing a god. Many worlds interpretation doesn't violate anything. It's maybe bizarre and weird and hard to wrap your mind around, but at least it doesn't posit any straight up nonsensical bullshit. I think that's the point of this particular sequence, because you can't prove it. All you can do is point to these two interpretations and apply the skills of rationality to them. And if you apply the skills of rationality, Copenhagen obviously loses. The exercise then is, are you going to just ignore the many worlds interpretation because it's so unintuitive and so clashes with everything you see in the real world that you're going to reject what your rationality training tells you and be like, no, I'm just not going to go at this point? Or are you going to be like, you know what, my intuitive understanding of things has been demonstrated to be flawed many times in my life. Am I going to reject many worlds this time? Or am I going to be like, you know what, I think this is probably right because these are the tools that point me that way. So I think it's a good exercise on really taking the edge case of how is rationality useful to right up to its limit.
I agree, and I think I was talked into I was won over on the value of doing these a few episodes ago. I'm trying to remember. The Copenhagen one is just about like superpositions collapsing upon being observed or something. Was that it?
Yes.
Okay. Yeah, that does sound weird. I'm not enough of a quantum physicist yet to say that it's obviously ridiculous compared to many worlds, but many worlds doesn't require a conscious observer to like make the universe happen.
Exactly.
So that does sound weird. I wonder if there's some steelman of that. But in any case, and he kept saying how bizarre and weird many worlds is. I mean, it's not, I don't know, it doesn't keep me up at night with how weird it is. And there's lots of things that don't break the laws of physics that we're fine with. Even if you can't interact with them in principle. He talked about shooting a photon at the speed of light, and once it goes actually really anywhere, but beyond a certain distance, it's like impossible to interact with in principle.
Mm-hmm.
The reasonable conclusion there is like, yeah, it's still going, right?
Mm-hmm.
And so this is maybe getting too into the weeds for just focusing on the LessWrong posts, but like, I was raised in the days of good old-fashioned science, falsifiability and Popper and all that, and was awesome. And that was all the ammunition about, that fueled our side during the New Atheism Wars. But again, I can't falsify that the photon continues to exist once it passes the edge of the observable universe, right?
Yeah.
It would be ridiculous for me to say that it vanishes. For all intents and purposes, it might as well not exist to me, but that doesn't mean it's not there. All that's to say is that the many worlds interpretation, I mean, it's all fun and games and hypothetical up until we can start jumping universes. So let's maybe this will be testable someday.
I was about to say, like, yeah, except then you said jumping universes, which is not a thing that Many Worlds says that you can do.
Well, is it strictly prohibited? I mean, if the universes are there, I'm not a quantum physicist, but
I believe the answer is yes, it is strictly prohibited. There is no jumping universes because everything already exists concurrently and you don't like jump between them.
Right. Yeah. If the alternate universes are as concurrent and as real as ours, there's not, a way in because there's no way out of ours. All right. Yeah. I think that's making sense. But in any case, yeah, no, I think you're right. And to reiterate, I think the punchline of what you're saying there is that, are you really going to reject your rationality at this point because your many times demonstrated to be flawed intuition is yet again saying this is just too unintuitive? And I think that's a really good rejoinder. That brings us to no individual particles.
This one, pretty quick, I thought.
Yeah.
Just reiterates, reminds us that...
It reiterates the title.
Yeah, exactly. Reminds us that the physics of our universe take place in a multi-particle configuration space. And since it's been a few months since we had a Less Wrong post, for a reminder, unfortunately you can't see this because this is an audio medium, but if you go back to the original post, there's the little 2D graph that shows a shaded area where particles can be, and it's like darker shading where they're more likely to be, and not shaded at all where they can't be at all, and various darker shadings where the two particles can both be in the same place, that kind of thing. That is the universe. It is a big cloud of probabilities of amplitudes. So in classical physics, the particles that are in this graph are the fundamental things. The configuration space is just an isomorphic way of looking at them. In quantum physics, the configuration space is the fundamental thing, and you just get the appearance of an individual particle, which is a heckin' difference. Does that make sense when you think about it?
Yeah, I think so. I mean, isomorphic just means like similar in whatever kind, or identical in kind, maybe, or in function. So like I've used the phrase like functionally isomorphic substitutes for neurons would, whether it's other neurons or transistors makes no difference. So in classical physics, the billiard ball style we're all taught, the little balls are the bottom of reality.
Yeah. They're the real thing. The graph is one way of plotting where they are and thinking about them and looking at them.
Right. And then in quantum physics, the configuration space is the fundamental thing, not the billiard balls.
Yes, the graph is
you get
the real
appearance of billiard balls.
Yep. So it's flipped. The billiard balls are ways of thinking about what is actually real, which is that space of probabilities. But that is the real thing. There are no balls anywhere. There is no spoon.
I don't want to jump the gun, but this does kind of jump us straight to the question of like, what is an individual point in the configuration space then? The answer is that it's physics, and physics is math. You've got to come to terms with thinking in pure mathematical objects. I admit that's still something of a hurdle for me. To me, pure math is like 2 + 2 = 4. And that's not a thing I can, rest my hand on and pick up and touch. So thinking of pure math objects as being things I can collide with is unusual. So I think I'm still missing some inferential bridging there, but we're working on it.
Yeah. I can't help you there.
There goes my help.
Sorry.
No worries.
Yeah.
I bet the rest of the sequence will help me get along there. So
at this point, the math is starting to leave me behind, and I am mostly resting on, yes, I can, in fact, imagine the universe where the configuration space is the real thing, and there aren't actual real particles. That's just an illusion.
I guess, illusion makes it sound like it doesn't exist. Like I can actually go up and touch it. It's water I can actually drink, right? So yeah. I can understand the graphs a bit, and I can follow, especially every Feynman quote pretty well, but I'm still struggling to grasp how this collection of this configuration amplitude that makes up this mug of water that I'm holding is in any sense not real. It's as real as I could ever want it to be, right? God, I feel like such a pseudoscientist, or like whatever, a huckster, just like regurgitating these words and
without knowing what they mean exactly.
Yeah, this is
that's
all
why I'm trying not to say the ones I don't understand.
All right, well, let's try to say the ones we don't understand about the rest of this post, or the ones that we do understand rather. So,
okay,
I do understand this. If I take a balloon full of photons and shake it up, the amplitudes are going to go all over the place.
Yes.
And if you try to label, imagine that you can label the original apparent photons. They're all going to be different places at the end, right?
Not only are they going to be at different places at the end, but they're going to take a zillion Feynman paths to get there. Meaning, remember how the previous sequence reading, we were talking about the photon doesn't just go directly from where it is to the mirror, bounce off at the angle of incidence, and go to a second place. It actually travels along every single path and bounces off every single angle of the mirror, or bounces off the mirror at every single angle, but they all either cancel out or reinforce themselves, so it looks identical to as if it just took the one path where it bounces off the center of the mirror at the angle of incidence.
Yes. Unless you're looking at a mirror made from a CD and you're looking at the shiny bits of that, then you get to see all the cool refractive bits, like we talked about, I think, in one of our previous posts. Some of our cool Discord people pointed those things out.
The particles will take every single path possible at every single way that they can bounce, not just the ways the classical laws of physics would dictate. So it becomes a whole weird cloud of amplitudes, and then they end up at other positions because those clouds cancel or reinforce in certain ways that end up with probabilities at a certain level in certain places, which is not the same thing as balls moving around chaotically.
Right. In our intuitions, for those of us, I'm speaking, I think, on behalf of all humans who aren't quantum physicists. Uh, I intuitively picture, again, billiard balls in a balloon, and I shake it around because this is a useful abstraction. But the important thing is that it's an abstraction, and I kind of picture them colliding like if I shook up a big bag of actual billiard balls in zero gravity or something, right? They'd hit
Mm,
each other, they'd bounce off the edges, whatever, and they'd be in different spots, but they'd move there from along lines, even if
mm,
they're chaotic and hard to predict. But that's not how it really works.
right.
Uh, like I said, it goes under a continuously branching evolution that involves each of the original bulges of the configuration amplitudes, and it's not that you don't know which photon went where; it's that there's no fact of the matter.
Yeah, yeah. Ooh, can I read this paragraph that he wrote, which is hard to read?
Oh, please.
The amplitude factor that corresponds to the balloon full of photons subspace, which contains bulges of amplitude subfactors at various different locations in the photon field, will undergo a continuously branching evolution that involves each of the original bulges ending up in many different places by all sorts of path, and the final configuration will have amplitude contributed from many different permutations.
It's kind of cool to think about. So back with the mirrors, the final result here is a factor of every configuration along the way, right?
Yeah.
It's just kind of it's fun to think about it that way. Well, let's hold on to that, and we can move into identity isn't in specific atoms.
Yes, this is a fun divergent train of thought. I think that goes off of all this.
Yeah.
So we're taking a quick break from quantumness in order to rip on the zombie people again.
I can get us started here.
Mhm.
So suppose I take two atoms of helium-4 in a balloon and swap their positions via teleportation. I don't move them through intervening space. I just click my fingers, and that causes them to swap places. Afterward, the balloon looks just the same, but the two helium atoms have changed positions. Now, did that scenario make sense? Can you imagine it happening?
Yeah, and here's the thing: if you imagine the world in the classic way, where atoms are the fundamental things, these billiard balls are the real things that exist, then obviously you could imagine it happening. But if you imagine the world where that graph with the shaded areas is the is the real reality, then you you literally can't imagine it happening because you say like I snap my fingers and the graph changes from being shaded in these ways to being shaded in exactly the same way. Like
Exactly.
what are you talking about? Nothing has changed. It's the same picture. To quote The Office.
Yeah, but I love that as a way to drive the intuition home, right?
Yeah,
Because you're right. Like in the classical way of viewing them, it's like, yeah, I've got billiard ball A and billiard ball B, and you told me they switch spaces, and okay, sure, I understand they're identical, but those two identical things change places. That makes sense. But if you show them again, like just the graph of probability, it's like, look, set my fingers, and the graph stayed the same.
yeah,
Now, can you tell me that these actually switch places? And
yeah. You're like, this part that I called A before, I'm calling B now, and this part that I called B, I'm calling A. Like, what are you talking about?
yeah, you can just change the labels on things.
Yeah, so the correct answer is that this is absolute physical nonsense if you have the deep quantum view internalized.
Yes.
Which brings us to
The transporter problem.
if you build an exact physical replica of a human, but you're using different atoms, is it the same person or just a copy? And of course, the answer being if you've really internalized that there is no such thing as different atoms, then what are you even asking? Atoms don't have different differentiable identity like that.
Yeah, and if that sounds unintuitive, I mean, just imagine the balloon having 4 helium atoms instead of 2, and swapping places of those, and the graph looks the same, right? And then
Right.
just keep adding those until you get enough atoms to make a person, and then swap all of those again.
Yeah, yeah.
Um, you end up with exactly the same thing, and
Mhm.
like the same in principle. For anyone to lose any sleep about like whether or not their consciousness or their self or whatever is lost in that process, they have to be imagining something above and beyond the atoms and their relationships to each other.
Right.
I don't want to say they have to invoke magic, but it's at least something that is not I'm trying to think of some charitable way to frame this such that the I wouldn't get in that teleporter machine people aren't offended. I guess they're hedging on the fact that, hey, I don't know exactly what's going on with this consciousness business. I'm not going to roll those dice, right? So
Mm-hmm.
I can see where they're coming from. Like I said, I probably would be the first one to get into one, but I'd be happy to be in the first dozen.
If I were to not get in a transporter machine, it wouldn't be because of this. It would be because I think, maybe the fuse is going to blow at the bad time or something.
Right. Or uh, depending on if how they dispose of the original. If it is deconstructed, that's great. If it's dropped into a vat of water and drowned, then no.
Spoilers for an amazing Nolan movie.
Not going to tell you which one.
Nope.
Yeah. So like I said, he's taking more of a dig at the zombie stuff.
Here's an interesting thing that he points out as well, because right now we're looking just like at individual atoms, but he expands it to all of configuration space, pointing out that the state of your brain from 1 second ago is not the state of your brain now. So even in the course of a single second, the joint position of all the atoms in your brain is going to change. Like, obviously, there's going to be some movement of some particles somewhere in your brain, and probably lots of particles will move in lots of ways. This will change far enough from what it was before that there's no overlap with the previous joint amplitude distribution. Like, the graph cloud of probabilities is going to move significantly, and that is the base reality. Like, there aren't individual atoms, right? So the base reality morphs a lot from moment to moment, and you're going to be made up of a completely different, non-overlapping volume of configuration space. The thing that actually makes you up in physical reality changes wildly all the time.
I might need that unpacked a bit because I'm on board with all of that until you say there's no overlap. 'Cause there's enough of it that I'm not falling apart and reconstructing and stuff, right?
Okay, yeah, all right. I guess by no overlap, he means not a complete recreation from what was before, which is like what people tend to think of in terms of atoms. Like, one atom is one inviolable thing. The configuration spaces are not that. You would have to have it be basically identical to what it was before to be the same thing as before.
Right. Yeah, and I guess he's talking about the joint amplitude distribution of presumably the entire universe.
At the very least, your entire brain and probably the entire universe, yeah.
Yeah, and I mean, if I just get up and move around the room, everything's changing, right?
Yeah, yeah.
Every particle in the room and every edge of it is impacting a slightly different gravitational pull on every molecule of my body. And if I move around the room, that changes a little bit. Yeah, so there's definitely shuffling happening, but not enough to where, again, I think maybe I'm just hung up on no overlap because there's not enough happening when I cross the room usually that I forget why I crossed it, right?
I love that usually. Yes. I think what he's hammering on here is that the real physical things that constitute the universe are these clouds of probability and not atoms. And therefore, what was the line? The notion that you can equate your personal continuity with the identity of physical, real constituents of your existence is completely hopeless, because the physically real constituents of your existence aren't atoms. They're these amplitude distributions, and those are changing all the time.
Yeah. And then the punchline being that the new factor over subspace looks a whole lot like the old you did, and not by coincidence. The flow of time is lawful, and there are causes and effects and preserved commonalities.
I love when we get to that later on in the sequences. And maybe this is another reason why the quantum sequences are important, because that's a very important thing. The future is a direct outgrowth of the present due to the lawful flow of time. So that has a lot to say about free will when we get there.
It does. That'll be fun. All right.
But yes, you are not just a weird, chaotic thing that bursts in and out of existence. You are absolutely a lawful flow from one moment to the next.
That's right.
Cool. Well, for next time, we get to have a little bit more fun with this before we get back into quantum stuff itself.
Yeah, I like the next one is Zombies, the movie.
Yeah. And that's just a really fun sequence post. We can't skip that one.
No.
And then after that, 3 dialogues on identity, which we will also be reading.
Awesome.